Hey everyone, this is Derek, and in this video we're going to look at polynomials, but this time as inequalities rather than just graphing or their features. And if you know what the graph looks like, these are actually super easy. I'm going to show you test points, but then I'm also going to show you that if you kind of got the graphing from the last video, you're just like, answer is this. So I'll show you both versions. So for this, the first thing we're going to want to do when we have a polynomial like this is get it factored so that we can figure out where our zeros are. So here we're looking for what multiplies to 5 and adds to 6. So that's going to be x plus 1 and x plus 5 is greater than or equal to 0. So I got zeros at -1 and at -5. So I'll come over here to this number line and mark those. And now what I want to do is grab, what that does is it gives me 3 intervals. I could have maybe picked slightly different numbers and had this look a little bit better, but there we go. So now you can kind of see I have 3 intervals. My function is 0 here and here. And what I want to know is what is it here, here, and here? Because if it's positive, great, that's positive things are going to be bigger than 0. That's one of the answers I want. If it's negative, not great, because negative things are not greater than 0, so that's the part I don't want. So what I'll do is I'll just grab a number in each of these regions and then figure out what the sign is. I don't even have to like exactly care about what the actual value is. So like if I'm doing this, I can just kind of go, so if I put -6 in here, let me write it all the way out once, just to kind of show you, and then I'll show you the shortcut that I kind of do in my head that hopefully will help you. So if I do this all the way out, -6 and 1 is -5. -6 and 5 is -1. So once you recognize you have negative times negative, you can just go, hey, that's positive, and then you don't care that it's 5. It doesn't matter that it's 5, it's positive. So boom, that region is positive. So then here, say I put in -3, this would be -3 plus 5, that would be positive. If I multiply a negative and positive, that's going to be negative in here. And then if I grab something off this region like 0, 1 times 5, that's positive, so this region is positive. So that means my solutions, and I have an equals on this, so I'm using solid dots. I want to include those endpoints. All my solution set's going to be all the places where it's greater than or equal to 0, which is going to be the positive regions. So out this way, and then out this way. And then I'll also ask you to give your answer in interval notation. So that would look like -infinity up to -7. And then we're using a bracket because of the equals. And then remember, union is how we paste those together. Another bracket up to -1 and to infinity. So the other way to do this thing is an x squared, right? And I have zeros at -1, -5. This is a parabola, x squared, and it's opening up. So that means my parabola looks like that. So anywhere it's above the x-axis, it's positive. That's what we're finding, is these positive values here. Anywhere it's below the x-axis, that's negative. That's what we just found right there. So again, once we're past that -1, we're back to positive. So if you know what the picture looks like, you don't have to do any of this test point nonsense. You can just go, it's parabola opening up. It's going to be positive on the edges. So I just got to get my zeros, and then that'll define my area. So that's where I like the graphing on this. And then you'll use this next quarter in calculus when you do the derivative test. You end up needing to know the intervals, the signs of the intervals. So this comes in handy there. This one, same thing, but we have to do a little bit of factoring. So I'm going to take an x out of there, and that's going to be an x squared minus 9 less than 0. And then factoring that, I get x plus 3, and x minus 3 less than 0. So I'm going to have zeros at 0, at -3, and at 3. And this time I don't have an equal, so I want to be careful to use open dots and then parentheses on my answer, because I'm not going to want to include those. And then since I have 3 zeros, if you chop something 3 times, you get 1, 2, 3, 4 pieces. And so if we do our test points, here if I put in -4, I would have, again, I'm just going to do the signs. If you're more comfortable writing it out, that's cool. I'm just going to go, this would be negative, and that would be negative. And so at -4, that is negative. And then, like I said, this is a 0, that's a 0, and that's a 0. If I put in -1, this would be negative, positive, negative. 2 negatives would make a positive. If I put in 1, I would have a positive, and a negative, so that will be negative. And then if I put in 4, as you can probably guess, positive, 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 so that will be positive. And this time we wanted the less than, so we want the negative region, so that's going to be through here, and then in between those two. So in interval notation, we have negative infinity up through -3, and then union 0 to 3. Oh, and then lastly, let me just do a quick little, so if we were going to graph this, or think of it as a graph, this would just, these are all to the first, so they'd all be crossing. It's going to be an x cubed. So this would start at the bottom, and it would come up, and it would turn around, cross through 0, and then go back up. And there's your negative and your negative, and there's your positive and your positive. So again, if you know what the graph looks like, you can actually do this a lot, at least on these ones, a lot easier, just kind of thinking of the graph.